I used to think driving was getting more and more dangerous, and one reason is the media loves to sensationalize car accidents.
Multi-car pileup in North Texas has killed at least 6 people. Incredible.
And with those kind of stories, I was surprised by how the fatality rate has steeply dropped over the decades, even with more drivers on our roads today. We save more lives because of better seatbelt enforcement and catching intoxicated drivers. Cars are also safer with crumple zones, airbags, and ABS brakes.
But did you know we've greatly improved the design and engineering of road barriers in the last 60 years? Like this connection between a guardrail and concrete barrier.
In the past, vehicles used to be crushed, but now they gracefully bounce off, and I'll tell you why later. We also removed these terminals from highways, which in the 60s made you look like a hot dog, and replaced them with something far safer.
My name is Andrew, and let's uncover how good road barriers have gotten to save more lives.
Roadside safety equipment is made by different companies, and their products undergo real-life crash tests to prove their products work. In the United States, that standard has gotten more rigorous over time, and the latest is MASH, or the Manual for Assessing Safety Hardware. Compared to the older 1998 standard, MASH uses heavier vehicles, faster speeds, and higher angles. MASH-rated equipment has to be built better to handle the much higher impact forces.
Europe uses a different standard, EN 1317, but the safety principles are similar. In this video, I'll be focusing on MASH and how it's made our roads safer.
MASH-rated products have 6 safety ratings. The lowest is TL1, with higher ratings requiring products to stop heavier vehicles at faster speeds. The highest TL6 barriers that can stop tanker trucks are massive structures and rarely used on our roads today. For each level, all equipment has to pass 3 tests. Number 1, it must keep the vehicle upright with no rollovers, which can cause severe injury to occupants, which means this product would fail and would need a redesign. Number 2, the vehicle can't tip more than 75 degrees or go over the barrier. That means this barrier does not pass MASH testing. Number 3, there could be no penetration or crushing of the passenger compartment, and impact forces must be below the maximum allowed. All of this data is recorded and analyzed to figure out if a product fails or passes.
MASH-rated equipment has been mandated for new installations like this concrete barrier, and is an important part of the safety system.
Barriers prevent vehicles from driving into hazards like buildings, bodies of water, and oncoming traffic. But crash barriers are themselves a danger. They're longer, closer, and easier to hit, which increases the number of crashes, even though severe injuries and deaths are greatly reduced. It's far better to have vehicles run off the road into a safe area of land called the clear zone, which allows drivers to recover or reduce the severity of a crash. Engineers can create clear zones by removing hazards and grading the land according to guidelines, which covers things like the steepness and the width required. But it might not make financial sense, or it's not possible to create a large enough clear zone, which is when barriers can be used. These barriers come in 3 categories: concrete, guardrail, and cable.
You often see concrete walls like this one. While it seems simple, there's some surprisingly well thought out engineering.
If you look at their profile, many aren't vertical, but sculpted to reduce crash forces. One hit, your vehicle rides up the slope surface, and this vertical motion dissipates energy, which reduces vehicle damage and impact on occupants. Unfortunately, this lifting motion can cause the vehicle to roll over under high speeds and impact angles. To improve this, engineers tested many shapes, and while the New Jersey barrier is popular, single slope and F-shape are better as they don't lift the vehicle as high, which increases stability and prevents rollovers. In comparison, vertical barriers minimize upwards movement. They're often used on bridges as you don't want vehicles to be catapulted over the sides. Unfortunately, that increases impact forces and wheel damage, which can cause the vehicle to veer sharply into traffic. As well, higher lateral forces can push your head through the window, which can cause head slap and greatly increase your chance of dying. For those reasons, you mainly see slope barriers on highways today. Concrete walls are often used where you can't have any movement, for example, if it's close to a hazard. When there's more space, you'll often see a semi-rigid system instead. These can use a box beam, or more commonly, you'll see a flat corrugated guardrail connected to a wooden or metal beam for support. These are driven into the ground and often use a strong post system, which is quite ingenious. One hit, the posts rotate outwards and down, transferring kinetic energy through the soil, which reduces impact forces. As well, the rail detaches, so it stays at the right height and in contact with the vehicle, which also prevents tearing. On older designs, the rail is more likely to remain connected and can rip, letting the vehicle through. This tearing can also happen if the post can't easily rotate, which pulls down the rail. The new, safer MASH-rated guardrails only use a minor height increase and connection change versus the older rail to better contain heavier vehicles and prevent taller ones from jumping over the guardrail. It's also likely there's an offset block that keeps your wheels from snagging. This helps the guardrail improve stability and reduce sudden impact forces on occupants.
Remember this guardrail and concrete connection I mentioned earlier? Engineers figured out they needed to add extra posts to prevent vehicles from being crushed.
If the connection between the two is not reinforced, the guardrail bends and tears, with the vehicle smashing into the concrete face with horrific outcomes. Engineers added posts to stiffen the connection and allow the vehicle to bounce off as it was designed. Finally, we have cable barriers that are placed in medians to prevent vehicles from flying across and striking oncoming traffic. These have existed for decades, as you can see in this 1930s Missouri transportation video. Modern systems use 3 or 4 cables to safely catch vehicles and are under high tension to withstand multiple impacts and reduce movement.
Unlike concrete or guardrail, there's some controversy with cable barriers. Critics say they're dangerous and only put in because of the low price. Transportation engineers argued they reduce serious injuries and could save more lives. Let's look deeper.
Cable barriers are several times cheaper than concrete and 40% cheaper than guardrails because it uses fewer materials and lighter machinery, which reduces logistics, construction, and product costs. You can also install cable barriers on slopes, which saves money on landscaping. In comparison, concrete barriers can require heavy machinery, a sewage system, flat ground, troublesome logistics, and more time. The big downside with cable barriers is the greater vehicle penetration, as it's easier to slip between the ropes. This is shown in 2 studies evaluating over 10,000 crashes which compared concrete, guardrail, and cable systems. From this, people say cable barriers are unsafe and cause way more deaths, but that's not completely accurate. In fact, these 2 large studies showed an equal or slightly higher fatality rate versus concrete.
As well, what isn't mentioned enough is that cable barriers can reduce injuries.
Cable barriers stretch when hit, which decreases injuries due to reduced impact forces. Both studies found a big reduction in total injuries. As well, the stretching helps prevent the vehicle from bouncing back into traffic and causing a second, more dangerous accident. More importantly, the lower price lets you build more cable barriers versus other types, and the added length saves more lives. That's important as we don't live in a world with unlimited money, and there are many construction projects and many miles of unprotected roadways.
I could keep going, but this isn't a video about cable barriers versus the world. Instead, I wanted to show that each barrier has its benefits and drawbacks. To pick the right system, engineers weigh factors like traffic, volume, vehicle types, and landscape.
So, besides the barrier itself, at both ends, you often find a protective terminal like this one that saves drivers if they run into it. In the 60s, the state-of-the-art was fishtail or spoon designs that tried to distribute the impact across more of the vehicle. These were widely used decades ago and were awful. Unfortunately, this acts as a spear when struck head-on and can result in catastrophic injuries. In the late 60s, turned-on ends were used, which bent the rail 45 degrees and buried it in the ground. These prevented spearing, but vehicles could easily vault or roll over, which caused serious injuries or fatalities. In the early 70s, various breakaway cable terminals, like this one here, were invented to minimize spearing. It works by having the end roll away, with posts breaking off to redirect vehicles into a clear zone. These were used for 20 years, but phased out as they were too stiff for small vehicles and could still spear occupants. In this test footage, the guardrail smashes into the side of the vehicle and would dice up any occupants inside.
Nowadays, we have energy-absorbing terminals that let people walk away from highway speed crashes.
For example, this is the MSKT, MASH Sequential Kinking Terminal System, and costs around $3,000 US. All terminals, including this one, have to do 2 things: protect occupants that hit it head-on and anchor the guardrail. The MSKT, when hit head-on, dissipates kinetic energy by crushing and kinking the rail while shooting it out the side. Its post and anchor are designed to break away safely as the head travels down the guardrail and slows and controls the vehicle. What I found impressive is the terminal has to do the exact opposite and provide tension when the rail is hit. The cable and ground strut keep the post and rail from being pulled down, which is called anchoring. Otherwise, the guardrail releases from the end post and the vehicle runs into the hazard. Also, if hit where the rail isn't strong enough to redirect vehicles, the MSKT safely lets vehicles through, which is known as gating. That's not a problem, as engineers add a clear zone behind it. While there are other terminals, I'm going to talk about one more because it's cool. This is the Trinity Soft Stop. When struck head-on, it crushes the guardrail vertically, pulls it through the impact head, and shoots it under the vehicle. You can see how the guardrail slides through the impact head as seen in this assembly video and what the rail looks like after it's been crushed. Not only does this keep the guardrail off the road, improving safety, but it keeps the rail anchored and maintains tension in the system.
While the terminals for guardrails were fairly compact, I discovered these larger units are different.
They're called crash cushions and are placed in front of fixed structures such as bridges, toll booths, and concrete barriers. Before crash cushions were created in the 80s, engineers used ramped ends, which produced dramatic and dangerous results. Nowadays, we use crash cushions in these three categories to safely stop vehicles. Starting with sacrificial systems like sand barrels, these slow vehicles down through the transfer of momentum. They're arranged by weight, from lightest to heaviest, so small vehicles can be gently slowed down and still protect heavier ones. These systems are cheap, around $3,000 for the parts, but anything hit needs to be replaced, and it's messy to clean up. These are also useful for construction sites, with one model using a metal sled that controls the vehicle as it crashes through the water-filled cartridges. There's also a mobile version that is mounted to the back of trucks that are used to protect road crews. Next, we have cushions like this QuadGuard M10 that are better for frequently hit locations. When hit, the steel structure collapses, but is designed to survive, and can often be reused by pulling it out with a truck. Afterwards, you have to replace the cartridges inside, which can cost around $900 each. Larger systems can use 6 of these, which can get expensive if hit often. For spots with many collisions, engineers use cushions that bounce back or can easily be reset when hit and requires less time and money to repair. There are many designs, but I found SCI's Smart Cushion particularly interesting. What's neat is the gas cylinder inside adjusts the stopping force based on weight and speed so cars and trucks have the right resistance. After an impact, the Smart Cushion can be quickly reset by pulling it out and replacing a few bolts. Other systems, like Traffic's compressor, use high-density polyurethane to absorb and bounce back after an impact. While restorable cushions can be double or triple the price of units that use replaceable cartridges, the repair costs are much lower, and with enough crashes, restorable units save money in the long term.
This is just one example of how engineers can maximize protection and justify how your money is spent. That brings us to how governments figure out how much money is worth spending to save your life or prevent a serious injury.
Those values are called crash costs and are used to determine if safety improvement projects are economically justified. Engineers compared costs like adding a barrier to the benefits like saving your life to figure out what safety measures should be added. Governments value your life and limbs differently depending on your location, but the average to save your life in 33 states is $4 million.
If you want to learn more about how these values were calculated and used, I recommend you Google the podcast Lies vs. the Economy by NPR's Planet Money if you're interested. While it's nice that the government is thrifty at spending your money, imagine being told saving your life isn't cost effective.
That's what happened in my province of Ontario on a stretch of highway called Carnage Alley, which had no median barriers. After a series of deaths from vehicles crossing the median and hitting oncoming traffic, local groups like Build the Barrier were created, and they lobbied to have the road upgraded with a concrete wall. The Ministry of Transportation, MTO, disagreed, and as you can imagine, people were not happy.
The MTO claimed that it wasn't worthwhile to make Carnage Alley safer because of a lack of traffic on that stretch of the 401. The government's position, Speaker, is appalling.
Well, with public pressure, a cable barrier was installed, and later the government committed to concrete barriers along the entire stretch. What I learned is that road safety can be about public perception as it is with engineers trying to protect as many people as possible. But I hope with this video you can appreciate our roads
engineers, and even the government a little more. As to the future of this channel, while I've focused on dashcam reviews, I want to do more videos like this one and reveal the hidden world of how businesses and governments pick and use products. Like, subscribe, and you want to support more of this content, consider donating. There's a link in the description. Would love to hear your comments, and thanks for watching.